Today, I'm in the big city trying to find people to teach them about perfect square trinomials and the difference of two perfect squares. You're going to learn about both of those in today's lesson when we talk about multiplying binomials with special cases. Before we start today's lesson, here are 3 things you need to be familiar with. First one, perfect squares. These are your perfect squares. The first 20 perfect squares. You should be very familiar with all of these, and especially have the first, 12, 13 memorized. And a perfect square just means 1 squared is 1, 2 squared is 4, 3 squared is 9. Any number times itself results in a perfect square. So those are your perfect squares. You're going to be seeing a lot of those in today's lesson. And then also remember, exponents, just what does it mean when something is squared? It means it is something multiplied by itself. And then the last thing, real quick review of FOIL when you multiply two binomials together. You do first, which gives you 3x squared, and then outside, which gives you 4x, inside, which gives you 6x, and last gives you 8. And then you combine like terms to get 3x squared plus 10x plus 8. If you know all of these things, it'll make today's lesson a lot easier. Here is our first special case. We're looking at a binomial that is squared. Now, the biggest mistake students will do is they try to distribute that exponent to the a and to the b to say that it equals a squared plus b squared. However, that is not true. Common mistake, but it is false. When you have a binomial squared, think about what it means to have something squared. It means to have something multiplied by itself. A plus b times a plus b. So now, let's think about how we would FOIL this. So we've got a times a is a squared, a times b is ab, b times a is also ab, and b times b is b squared. And then combine the middle terms like always. How many ab's do we have? We have 2 of them. So this right here is going to be good to know. If you look though, what did we do? We completed FOIL. So in today's lesson, if you know how to FOIL, you know how to get the answer to every type of problem. However, I would like you to get to know this pattern right here and see if you can solve some of the problems using the pattern instead of FOIL. Alright, here is our first example, the binomial x plus 7 squared. We're going to do this 2 different ways. One where we write it out like this and then use FOIL, and then one where you can see how you can get the answer just knowing this pattern and not having to do FOIL. So think about x plus 7 squared. What that means is x plus 7 times itself, x plus 7. So if we were to now FOIL this, we would have x squared outside plus 7x, inside plus 7x, and last 7 times 7 is 49. And then combine like terms, so x squared plus 14x plus 49 is our answer. But now, instead of doing FOIL, let's look at this special pattern. We started with x plus 7 squared. And in our final answer, the first term is going to be the first term squared, so x squared. And then plus, we have this 2ab. What that means is multiply the first one and the second together and then double it. So 7 times x is 7x, double it, you get 14x. And then finally, you take the second term in your binomial and square it. 7 squared is 49. So technically, you can do FOIL every time and get the right answer. I would like you to think about the special pattern, because when we factor, meaning we go backwards, it's going to be helpful to really understand this special pattern. Our second example is 5y plus 1 squared. And remember, anytime you have a binomial squared, it means you just have that binomial multiplied by itself. So if you want, you can write it out twice, 5y plus 1 times 5y plus 1. And then you can do the full FOIL, first, outside, inside, last. But if we don't do FOIL, you can also get the solution using this special case. A comes from the first term, B comes from the second term. So if we use that special pattern, we can, instead of doing FOIL, go straight to our answer. A squared means take the front term and square it. 5y, when you square it, square both of them, so it's 25y squared. And then 2ab means that you multiply a and b together, so in this case 5y times 1 is 5y, and then double it to get 10y. And then last, b squared, take your second term and square it. 1 squared is 1. And there's the answer. You'd have gotten the same thing if you would have FOILed it. Okay, here's our last example for our first special case. T plus 6 squared. Using the pattern, just take your first term and square it. So our answer will be t squared, and then plus 2ab means multiply these two together and then double it. So 6 times t is 6t, double it to get 12t. And then last one, take the second term and square it. 6 squared is 36. And voila, there's your answer. Here is our second special case, and at a quick glance you can probably tell it's almost identical to the first one. Only one thing changes. When you have the binomial a minus b squared, so the only thing is we went from an addition sign to a subtraction sign, we write it out twice and then FOIL. A times a is a squared. Outside, you'd have a negative ab. Inside, a negative ab. And then last, negative times a negative goes back to a positive b squared. And then when you combine the middle terms, you'd have a negative 2ab. But notice that that last term is always positive, since you have two negatives when you're multiplying in FOIL. So our second one, we'll do 3 quick examples using that pattern. Alright, here are your 3 examples. And remember, you can, on every single one of them, write them out twice and then FOIL to get your solution. But for now, I'm going to use this special pattern. If you have x minus 4 squared, take the first term and square it, so we have x squared. Next one, multiply the two terms together. Negative 4 times x is negative 4x, and double it, so it's negative 8x. And then take your second term and square it. Negative 4 squared is negative 4 times negative 4, which is a positive 16. So in this case, you'll always have a subtraction sign followed by an addition sign. Alright, second example. Square the first term. 9x, when you square it, you have to square both of them to get 81x squared. Now, we have to multiply our two terms together. Negative 8 times 9 is negative 72, but we still have to double that. So you're going to get a negative 144x, and then square your second term. Negative 8 squared is a positive 64. And then real quick, last one, square the first term, x squared. Multiply them together and double them, so negative 7x doubled is negative 14x. and then square the second term is a positive 49. So there are your three examples for our second special case, multiplying a perfect square binomial. Here's our last special case, the difference of squares. So this time, instead of having a binomial squared, we have two binomials multiplied together. We have the exact same numbers, you just have one with addition and one with subtraction. So let's look at what happens when we FOIL these two binomials together. We first have a times a is a squared, a times negative b, negative ab, b times a positive ab, and then a b times negative b. Positive times a negative is a negative, and then b squared. Now look at what happens when you combine the middle terms. Negative ab and a positive ab cancel out because one is positive, one's negative, and you're left with a squared minus b squared. So the result is why we call this the difference of squares, difference meaning the subtraction of two perfect squares. Here are the three examples for the special case, the difference of squares. So for all of these, you can use the FOIL method to get your solution, but in all of the cases, since you have the same thing in both binomials except one addition and one subtraction, your middle terms will always cancel out. So why not just use the special pattern a squared minus b squared? All you have to do is take the first term in the first binomial and square it. So we have x squared. It's always subtraction, and then square the second term. 8 squared is 64, and then you're done. Look at the second one. If you squared 2x, you have to square both of those, so it's 4x squared, and then minus square the second term. 3 squared is 9. And then last example, square the first term, x squared, minus square the second term. 5 squared is 25. And there you go, all of them complete. Look at all these people that showed up at Times Square to learn about multiplying binomials with special cases. Woo! Good luck with the lesson.